All right. So we're going to quack here today. Quack about how we think about data infrastructure through the lens of scale, performance, and usability. So I started my career about 22 years ago. And prior to that, I was a student. My first big student project failed because of a big data problem. Now, it was really that I didn't know a thing about indexes. So I was throwing more and more hardware at a problem and building like bigger and bigger MySQL machines. But then I went to work full time and I had friendly DBAs to create my indexes for me, which was super nice. And then later I would go to work on Google Sheets. And it was really interesting. People loved using Google Sheets to back simple applications. They built applications on top of a spreadsheet. Imagine that. Then I worked on App Engine. Infinite Google scale, so long as you can write software differently. Everyone wanted the scale, but nobody wanted to change how they thought about building their applications. Then I worked on BigQuery. Infinite Google scale again, and pretty high performance, as long as you learn to write data differently. There were no joins at the time that I worked on Google BigQuery, and everybody wanted joins. So then I was at Neo4j. The number one objection that we got, this thing can't scale, as it wasn't distributed. So they siphoned many engineers from other teams and built a huge team to enable distributed graphs. Overcame the objection, but not really needed. Hardware had advanced. And before I was at MotherDuck, I was at Databricks. Many users wanted single node Spark clusters because that's all that they really needed. And they were bogged down with the complexity of stack traces of distributed systems. And now the hot thing of the day is DuckDB. It feels kind of self-serving to say that, but if you watched the internet recently, it is true. Why? Well, first of all, it is single node. It is scale up. It is simple. And we've learned that scale matters, but the faster time between our problems and solutions also matters. And the way we get there is by being more focused on what the user actually wants. So let's talk about scale. Back in 2012, when I was on BigQuery, no matter the definition of big data, we knew that the size of your data was going to grow tremendously huge, bigger than you could possibly imagine. And BigQuery was going to handle that. And I believed that at the time. I would write queries, and those queries would execute on 1,100 machines, each handling a few rows of a column. And half the results were actually thrown away because every query got sent to 2 machines to make sure that the fastest one is the one that counted. But these machines needed to do a lot of talking with each other in order to enable that. In the end, though, the reality remains, though, that people really don't have that much data. We use our data from last week, from last month, from last quarter. The rest just sits there. It has no use for the business. We've already aggregated and reported on this data. And of course, even if we do have a ton of data in our tables, our actual workloads for analytics only touch a small amount of that data, only touching a few columns that are heavily compressed. We build this infrastructure so not much of the data actually needs to be read for the average query workload. Now, it is true that, yes, some people do have petabytes of data, but I would say those are the data 1%. Most people are not analyzing petabytes of data on a regular basis. So things have changed. Hardware has changed at the same time as the data is not as big as we predicted. The data that we actually need to access isn't as big as predicted. Our queries are only touching a small part. The machines have gotten, from 60.5 gigabytes of RAM on an EC2 machine to 25 terabytes of RAM, a 400x difference in the amount of data, amount of memory that these machines have to operate. So the machines of yesteryear are like this, they're tiny. Today, we have machines that are much bigger. These are built to handle distributed workloads. And why? When one machine can actually handle the workload of hundreds of machines from the age of 2012. This is the difference in the transitions on Keynote versus the transitions on Google Slides, speaking of scale and performance. Um, so we can have one big machine, and that big machine can actually handle the workload without the complexity of distributed compute. So why are we still demanding distributed compute? Why are vendors still building with all this needless complexity? I'd say it's psychological. We always feel that our data will be larger, the largest, as some might say. We think that we need distributed compute to get performance, and vendors are optimizing performance on huge workloads. We're looking at these standard benchmarks. We all dream that we'll have this 100 terabyte data warehouse that we need to analyze because we have so many sales, so many customers. And then we have the privilege to argue over workloads taking 7,000 seconds or 8,000 seconds. But the reality is most of us shouldn't care about the performance on benchmarks. We should care about how long it takes us to go from our problem to our solution. So whether a single query takes 30 seconds or 35 seconds rarely matters. What matters is the usability of the tools that we use. This is what gives us the competitive edge. Simple improvements to SQL can have a huge impact. Why make me type the names of all the columns in my group by in order to do my aggregates? Similarly, why do I have to do select star when it's really kind of needless? I'm already writing a dumb query. Why not make it dumber? Also, I should be able to access data on the internet just as easily as I access data on my local machines. And I should be able to join local CSV files and data within my warehouse together in the same query. Of course, SQL can be a pain at times. If I miss a slash in a date format spec, I could spend minutes trying to find it. That is what impacts performance. Or let's say I'm querying the New York City 311 data as I'm showing here. Maybe I'm depending on the value of a specific column, the facility type column. It would be helpful to know that that is null in 91% of cases. These are the types of things that really matter. So I redefine performance. You might be a little angry at me for that, but doesn't the query performance actually matter? Maybe not for static dashboards, but for dynamic ones, for exploratory analytics, of course the performance matters. Let's imagine that I have a slider. Moving that slider takes 7 seconds to get my result. And that's actually fast compared to my experience. I'm being a little generous. What if I could take that query and instead of returning the result in 7 seconds, I can return the result in 100 milliseconds? This type of new experience is possible by bringing the data closer to your laptop. And your laptop is fast and it's underutilized. So let's focus on the scale that matters. We can have a faster time between our problems and our solutions by being more focused on the user and respecting the interplay between hardware and software and between software and the user. And that's all I have. Any questions? Yes. That's fair. My presentation was and my background is focused a lot on the analytics side. I still think that fault tolerance, it used to be if you wanted a fault tolerance Sun cluster or Dell cluster, like you'd spend out the wazoo to get that. It doesn't cost that much anymore. You can spin up, if a machine went down, in my first job out of college, you would literally order a new piece of hardware and have that new piece of hardware delivered and installed, and that could take weeks. Nowadays, a machine goes down in like an EC2 world or something like that. What, it takes you 10 seconds, 30 seconds to spin up a new one. Sure, it does matter in some types of applications. I can't ignore that. But I think for a lot of analytics workloads, the hardware has become reliable enough that it doesn't really matter. I mean, it's evolving. DuckDB is a new technology. MotherDuck, we just opened up our beta in September. Um, I think that the way that DuckDB was originally designed, it was around data science workloads and around academics primarily. And those folks were just using DuckDB locally as a library in Python, and they were super happy, and they didn't even need a server. They designed the file format so that you could just have a single file, not a file representing every table, but a single file representing a whole database. And so it was easy to move stuff around. As you saw it get adopted outside of that community, we did see a lot of use of it in the ETL sense, and people are experimenting with, even things of like how to spin up a bunch of Lambda jobs to do our ETL workloads. Um, where I think that it's going to go is more of, yes, there is going to be some smartness in terms of getting the data to your local machine as you're doing your analytics. We're doing that already in WebAssembly in the browser. There's a complete copy of DuckDB running in our browser so that when you do uh, inspections on query results and you do a pivot or you do a filter, it's actually just running that in DuckDB on the result set that's in the browser. So I think we're going to see more and more, but yeah, today, it's still a traditional world. We're just trying to push the edge of the envelope here. Yes. Yeah, I mean, so I'll start off by saying I listed a bunch of my previous employers there, so no one hopefully will recognize what this is. But there's plenty of environments that I've been in, including people that make large scale data systems, where you didn't have access to the data at the central source, at the data warehouse or lake house. But like I had access to Salesforce or to Marketo, and I could go there and dump that data out and load it on my local machine and mess with it in Excel. Or frankly, oftentimes I re-uploaded it to the same data product in a different account. Um, and this is like a common pattern. So I guess my first response is that it would be better if it was in a controlled fashion than in an uncontrolled fashion like that. Because people will find their way around restrictions. My second answer will be that, we do think that there's a possibility that we can have encryption keys where the data is encrypted at rest locally using a key that can be revoked by the server. And you can then handle it that way. But the reality is that a lot of this data is actually coming down to your local machines anyway. It's just outside of your control. All right. Thank you.